Hello, it's Dr. Papelka Brown, and I am going to walk you through a few examples of combining perimeter and algebra. So you've shown me that you remember how to do the basic perimeter. So I'm going to walk you through some examples of pumping it up a notch and adding some algebra to it. But I'm just going to double check and make sure we're all on the same page. The first thing we need to make sure you remember is that perimeter is the distance around the outside of an object. So for example, if I have a rectangle, the rectangle I have right here, it's telling me that the width of the rectangle is 2 inches, and it's telling me that the height or the length of the rectangle is 1 inch. And hopefully we also recall from previous years of school that this little kind of hash mark right here and this little hash mark right here, the fact that each of them only has one hash mark tells me that they're congruent, that they're the same length. So if the side on the right is 1 inch, that means that this side over here on the left is going to be 1 inch as well. And then because the top has 2 little hash marks and the bottom has 2 little hash marks, that tells me that if the top is 2 inches, then the bottom side is also 2 inches. So if I am going to find the perimeter of this rectangle, I would simply add all those sides together because it's the total sum of the outside. So I would do 2 plus 1 plus another 2 plus 1. So the perimeter of this particular one, so again I would add the 2 plus 1 plus 2 plus 1, which means I would get a total of 6, and don't forget your units, inches. So the perimeter of this particular rectangle is 6 inches. The second piece of background information we need to recall, in addition to what perimeter is we need to remember what like terms are. And this isn't the exact definition because there is a little bit more to it, but for now this is going to do. Like terms are when you have terms that have the same variable, and then we need to remember that constants or numbers are always like terms. So let's look at how that would play out in an example. So I'm going to simplify this particular expression here by combining the terms that are like. So I've got my 5a, and then the other term that has the same variable is a 6a. So if I put together positive 5a with a negative 6a, that is going to leave me with 1a, and it's going to be a negative a because those 5 positives are going to cancel out 5 of those negatives, but they're still going to leave 1 left over. I'm going to go ahead, since I've combined those, and I'm going to scratch them out. The next thing I have is a 2x, but I don't have any other x's to combine that 2x with. So when I'm simplifying this expression, I am just going to leave it down here at plus 2x, but then, and so that one's taken care of. And then finally, I've got a 3 and a 7. Remember, numbers are always like terms and can always be combined. So I'm going to put those together to get a 10. So if I took that expression and I simplified it by combining the like terms, I have a negative a plus 2x plus 10. Now, it is important to note that I really could have done those in any order that I wanted to. So I could have had like 10 plus 2x minus a, or whatever order, as long as I've got the negative in front of the a, and as long as the 2x and the 10 are positive like they should be. So how does this play out when we have example problems that combine perimeter and combining like terms? Okay, so let's look at a few examples. This says, for each problem below, find the perimeter of the polygon as an expression in simplest form. So in other words, we're going to add all the sides together and combine them using like terms. So if I'm looking at example number 1, I'm just going to add all 4 of these sides together. I have a 3a, a 3a, a 3a, and a 3a. So remember, perimeter is adding every side together. So 3a plus 3a plus 3a plus 3a. You guys probably already see where this is going. 3, 6, 9, 12 a's is what I should get for the perimeter of that shape after I've simplified the expression. Number 2 is missing a couple of sides, but because it's a rectangle, I can still figure out what all the sides are. If this top one is A, that means the bottom is going to be A. And because this one on the right is A plus 2, that means the one on the left is also going to be A plus 2. So again, to find the perimeter, I need to add all 4 sides together. So I've got an A plus A plus 2 plus another A plus another A plus 2. So if I add all of those things together, I've got 1, 2, 3, 4 A's. So I'm going to combine those. And then I've got 2 plus 2, which means it's going to be 4. So the perimeter of this shape is going to be 4A plus 4. I'm going to do one final example for you before I turn you loose. And we're going to find the perimeter of number 3. So I'm going to write all of the sides as an expression. So I've got 6V plus S, which I'm going to add to 5S minus 4V, which I'm going to add to 2S plus 5. So if I combine my like terms, I have, let's look at what I have that's the same. So I've got 6V, which pairs with negative 4V. So 6V minus 4V is going to be 2V. I'm going to write it up here in the top. Those are gone. Then I've got, let me change colors here. I've got an S plus 5 S's plus 2 S's, which means 5 plus 2 plus 1 is going to give me 8S. And last but not least, I have this 5, which doesn't have any other numbers to combine with, so it's simply going to be a 5. So the perimeter of this shape is 2V plus 8S plus 5.